All right, good. Still technically morning, my EM aficionados. It is the day after December 7th, so it is now Monday, December 8th, and I am actually at home today dealing with a home repair, so I'm not going into work, at least not yet. But I had an idea as a follow-up to the video I just did yesterday about using the FFT for calculating despacing from your images. And there was an important nuance from that I wanted to discuss. I actually put a comment about it on the video, but I thought this would be a great, just a quick hitter video to do. So um, what I want to talk about is computing the FFT from arbitrary areas or dimensions. Okay, so I'm going to go ahead and open up ImageJ, and this is the same image we looked at yesterday. Okay, so what you have to keep in mind, the FFT algorithm requires your image to have power two dimensions. Okay, so the image has to be square and has to be power two dimensions. Okay, so 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, you get the idea. Okay, so that is a requirement of the FFT algorithm. You can compute the discrete Fourier transform from an arbitrary rectangular area. Okay, that can be done, but again, the FFT algorithm specifically relies on the area to be square and power two dimensions. Okay, but the point I wanted to make is that you can isolate the FFT effectively from any arbitrary sized or shaped area. Okay, it doesn't have to be square. It doesn't have to be power two dimensions. Okay, and I'll show you how. So the image that you calculate the FFT from has to be power two dimensions, but the area doesn't have to be. Okay, I'm going to show you why here in a minute. Okay, so we have the rectangle tool here. Okay, so if you hold shift, it draws a square. Okay, you can see very clearly that I'm going to put this up here because this is going to give a more interesting FFT. You can see very clearly my pixel dimensions are 194 by 194. Now that is, of course, not a power two dimension. Okay, so when you calculate the FFT from this area, now you don't have to actually crop this. You just have to select it and then go to process FFT, and that will compute it from just the area that you have selected. Otherwise, you can do Control-Shift-D to just isolate that area, and then you can compute the FFT, but it will do exactly the same thing. We can leave it here just to make this a little easier to see. Okay, so if I want to compute the FFT from this, okay, you can go to Process FFT and then FFT. So you can see what it's done here is the dimensions of my FFT are 256 by 256. So what ImageJ did is it basically created an empty 256 by 256 image, and it put this 194 by 194 snippet inside of that empty image. Okay, so we call that padding the image. This is something that I talked about in my fundamentals video. So I can actually show you how to do this manually. You can click New, you can click Image. I'm going to actually make this, I'm going to switch the type here for the image to 8-bit, but we'll fill with black, and we'll do 256 by 256 and click OK. And then I'm going to actually convert this to 8-bit. So we'll go type 8-bit, and then I can do Control A, copy, and then paste. Okay. And then now I can compute the FFT from this. Oops, sorry. And there you go. Okay. So if I do the same thing here, okay. Now I don't know, you can see that actually in the padded image that the cross-shaped artifacts are a little bit more distinct. That could mean that when it's actually doing this, it could be doing some kind of a window to the ROI. That's very possible. I don't know that for sure. But we have these hard edges here, right, where it goes from image to 0. And so that's probably why we're seeing the enhanced cross-shaped artifacts when we manually pad the picture like this, okay? But in essence, it's doing the same thing, okay? So now the neat thing here is that you can make this reduced area any shape you want, okay? So let me go ahead and close this. I'll close the FFTs here. We'll keep this one open. So what if I want to make this a rectangle like that, okay? So now this is 824 by 114. So my largest power two dimension would be 1024 by 1024. Okay, so we'll go process FFT. And yes, you can see exactly, right? So my FFT has 1024 by 1024 dimensions, but now, right, I have isolated the area effectively from just here. Now this does add noise. When you pad the image, it does add noise to the FFT. Okay, so there is a trade-off, but this will allow you to isolate the FFT from any arbitrary area that you want. Okay, so this doesn't have to be a square or a rectangle either. This could be, actually, let me duplicate this so we have it. Okay, so we've got these two ROIs. So what if we wanted to do a circle? Okay, we could do a circle or even an ellipse. Okay, so again, it's saying 516 by 136. So that's going to make it a 1024 by 1024. So we can go process FFT, and there you go. Okay, so it's doing the same thing. So I can even do this from an elliptical area if I want to. I could even do it from, let's see if this freehand thing works. I think this probably still, but I could do this. Whoops. Okay, so let's see if that will let me do that. I don't know. It's a freehand selection. That's saying 512 by 512, so I'm guessing yes. Let me try this again here. See, it's not showing what the dimensions of this are. 512. So let me make this actually a lot smaller here so I can see. Okay, so if I do FFT from this, yes. Okay, so it is doing this from even these, weird shaped ROIs. Okay, so it doesn't even have to be like a nice normal shape when you do this. It could also be like a polygon here. Yep, there you go. So again, the dimensions of this, like the smallest power two would be a 1024 by 1024. If we do crop there, yeah, so it crops it, right? So 612 by 170, right? So the largest power two dimension would be 1024. And let me see if I do just the weird shape here. Will it let me do that? It will, yeah. So again, that's 434 by 132. So that should be a 512 by 512 FFT. And it is, okay? Okay, so yes, that is what I wanted to share with you, is just that you don't have to, right, do the FFT um, from a nice square power two area, okay? So when you're doing this, right, ImageJ is creating a padded image. It may have some kind of windowing on it. Considering the difference we saw between the manually padded image and the one that's just directly computed, that's probably the case because we saw the reduction in the cross-shaped artifacts. But yes, that is the additional video that I wanted to show you. So actually, let me see here, because I'm curious here. If I just isolate this, this is amorphous alumina. Oops, duplicate. Okay, so let's see here. Now there actually is some, yeah, there is some ordering in that, but Yeah, so you can see, I mean, about what we would expect. So 512, yep, and that would be the smallest power two dimension. So yeah, seems to be consistent here. But yes, that is the additional kind of quick hitter video I wanted to do about computing FFTs from arbitrarily sized and shaped ROIs using ImageJ. So hope you're having an awesome Monday and look forward to the next video. Take care, everyone.